Hello class, in today's video we're going to be going over again the line of best fit. Now I'm hoping through this video you're going to have a better understanding of how you could actually draw the line of best fit as well as to find the equation for the line of best fit. Now remember, in our previous lessons we said that the line of best fit is a straight line drawn as close to the center of all the points as possible, obviously neglecting and ignoring what the outliers are going to be, okay? So just think of it as being the average and you try to want to draw it towards the center. So if you're drawing it accurately, then this is what it should look like. Remember, everyone's line of best fit is going to be quite subjective. It is going to differ slightly, but keep in mind when you are drawing the line of best fit, what you're trying to aim is that you should have roughly, and that's the key word here, you want to have roughly the same number of points that are found above the line as well as below the line, okay? So what do I mean by this? Well, as you can see over here, at the top hand side of here, I've got two coordinates that are found above the line, and I also have two coordinates or two values that are actually found below the line. And because they are the same, this is therefore a really good line of best fit that summarizes this particular data set over here. If you guys remember from our last lesson, we said that any straight line can be represented by this general equation here, which is y equals mx plus c, where m represents the gradient, which is essentially the slope, okay? So that means rise over run. So therefore it's the change in y over the change in x, and I've shown you the formula previously of how we can calculate that. And what the letter c represents in this particular equation over here, this represents your y-intercept. The y-intercept is the position or the number along the y-axis where your line of best fit crosses through, okay? So in this particular example over here, your y-intercept is equal to -3 because that's the coordinate of where this straight line passes through, okay? Now, in order to actually calculate the gradient, I've previously given you this formula over here. So, and that's calculated by going y2 minus y1 all divided by x2 minus x1, okay? And what these y2, y1, x2, x1 represents is they just represents the coordinates, okay? So you need to choose two easy coordinates that are found along the line of best fit. And I can't really stress this enough because often students choose coordinates that are not positioned on the line of best fit. I also do want to mention that when you are choosing two coordinates, these two coordinates don't necessarily have to be a part of the data set. So for instance, students might often use like these coordinates over here, let's just say as an example, but notice how these two coordinates, which are part of the data set, are not exactly along the line of best fit. The coordinates that you choose doesn't necessarily have to be part of the data set, but they need to run through the actual line itself. So in this example of here, the two coordinates that I will choose to actually find my particular gradient would be this one over here, as well as this one over here, okay? And I can readily see and kind of have a better exact value of what these coordinates are, as opposed to choosing what this is going to be, as well as this, okay? So make sure you are choosing really easy coordinates to calculate your gradient, okay? And then afterwards, what you do is, once we found out the gradient, then you could actually work out what your y-intercept is going to be by substituting one of the coordinates that you used earlier on to calculate the gradient to find your y-intercept, okay? And when you're doing this, make sure you are selecting the easier coordinates or the coordinates that have the smaller values, okay? And I just want to clarify again that when you do find your equation of the line of best fit, this is going to be slightly different compared to my one or other people because it is slightly subjective, and this will depend on what coordinates that you've chosen to calculate your gradient and such and such. So what we're going to be doing now is we're going to be going over 4 review questions, okay, where you need to actually to find out the line of best fit, and then you're going to be comparing your answers with my answer. It is really important that you nail this down so that we can actually continue on in the next lesson of how we can do extrapolation as well as interpolation, okay? So in my very first example over here, I want you to actually find the equation for the line of best fit. The suggested time frame is 5 minutes, and then we'll go over our answers together. Now in this case over here, remember our first step is to choose two easy coordinates, okay? And the two easy coordinates that I'm selecting are these coordinates over here. Once you've identified the coordinates, remember to actually label them as x1, y1, x2, y2, okay? So this over here, I'm going to label this as x1, y1, and this is going to be x2, y2, okay? And once I've kind of label them, then it's really easy for me to then calculate the gradient, okay? So remember, this is the formula to calculate the gradient. Your y2 value is equal to 70, your y1 is equal to 120, so therefore it's going to be 70 minus 120 all over 4 minus 2, okay? And if you put this directly into a calculator, you're going to get negative 50 on 2, which then can be simplified to negative 25, okay? Now, once we've calculated the gradient, all we need to do now is calculate the y-intercept, okay, guys? So firstly, I'm going to substitute my m value because I now know what the m is. This is, as I said, the general formula of the general line. So therefore, substitute this in. And now what we do in order to solve for the y-intercept, which is c in this case, is we substitute one of the coordinates earlier on to calculate the gradient, okay? So you could either substitute 2, 120, or 4 and 70, okay? But remember, we always want to go for the easier one. So in this case, the one that has like the small numbers collectively as a whole is 470. But just keep in mind that if you do substitute the other coordinate, you will still get the same answer though, okay? So if I did this, if I did this, it would therefore be like this, okay? So remember, you're substituting y over here and x over here. And once you do this, you can then simplify this. So therefore, negative 25 multiplied by 4 equals to negative 100. Now, in order to solve for c, we need to get c by itself. So notice that you've got the negative 100 on the right-hand side of the equation. So in order to get rid of it, we're going to be adding it by 100 to both sides of the equation, okay? Whatever I do to one side, I must do the same on the other side, since an equation is very similar to a balanced scale. So if I did this, this will therefore cancel out. So therefore, c is equal to 70 plus 100, and this is therefore equal to 170. And therefore, you need to rewrite your full equation. So it's going to be y is equal to negative 25x plus 170. Now, I always want you to check again to see whether your y-intercept is a reasonable value. So if you kind of look up here, notice that if you was just to eyeball this, this does look like it's going to pass through the 170 value. So therefore, your y-intercept looks pretty legitimate. Now, class, this is the exact same question as the one I just showed you in the previous slide, but what I'm going to show you in this example over here is that what would be the difference if you actually use this coordinate over here as opposed to this coordinate which I've used in the previous example, okay? So look carefully as how this will actually impact your gradient as well as your y-intercept. So in this case over here, we're going to be doing the exact same thing to calculate the gradient. So therefore, I'm going to label this as x1, y1. This is going to be x2, y2, okay? So substitute this in, and now ultimately, you're already going to see a difference in your gradient. So in this example over here, your gradient is now going to equal to negative 20, whereas in the previous example, it was actually equal to negative 25. So we'll follow the same steps again. Now, in this case, substitute one of the coordinates. So I want to substitute 2, 120 this time. As I said, it doesn't really matter at all, but obviously choose the coordinate that has small values in general. So if you did this, it would look something like this. So therefore, go negative 20 multiplied by 2. This equals to negative 40. And now, in order to get rid of this negative 40, I'll actually add plus 40 on both sides to get rid of this. So therefore, c is equal to 120 plus 40. So therefore, c is equal to 160. Therefore, this is going to be equation, okay? Now, beforehand, your equation looks like this. Y is equal to negative 25x plus 170, okay? Now, if you actually did something similar in this example here, your answer is still going to be correct because you still did the correct math and everything. But the only reason why you're getting different values, again, is because you're using different coordinates. Not because you substitute a different coordinate, because earlier on I used the second coordinate. The main difference is because you use a different coordinate set compared to the other one. Now, in this case of here, this is going to be less accurate because you can easily see that 160 is over here, and we can kind of already tell that your line of best fit passes a position that's above 160. So therefore, this is more accurate and closer to the true equation for the line of best fit, okay? And this is just something that I wanted to point out first. Alright guys, what I'd like you to do now is have a go at this particular question over here and then compare your answers with my answers. Now, if you did this correctly, then I'm going to be using these two coordinates over here. Again, I'm labeling it as x1, y1, x2, y2, and then I'll find out my gradient, okay? So if you did this correctly, your gradient is equal to 5 on 3. Now, you could actually put this into a decimal form, but I'm just going to leave it into exact values because in year 11, year 12, if you do decide to do maths methods, then you should be very comfortable with dealing with fractions, okay? So please try not to be afraid of fractions. But if it makes your life easier, then please actually use in decimals instead, okay? So once we do this, we just substitute it into our equation, and then we'll substitute a coordinate to find the y-intercept. So I'm going to be substituting 75, 500. So if I did this, then this is what it looked like. Simplify this, so put this into a calculator. What is 5 on 3 multiplied by 75? This gives you 125. In this case, to get rid of the positive 125, I'm going to subtract both sides by 125. So therefore, C is therefore going to equal to 375. And then for rewrite your full equation, okay, in the exact form. And we can really tell that in this case of here, this goes up by 125 increments. So therefore, this does look legitimate. Your y-intercept does look like it appear to cross through 375. And for the very last question in today's lesson, I want you to please do this question over here. So please pause this video, and what I'm going to do is I'm going to be choosing these two coordinates to find my gradient, okay? So again, label it as x1, y1, x2, y2. Your gradient for this particular example over here should equal to 0.025. Now notice for this case, I've converted into a decimal, but as I said, again, it doesn't really matter at all. Then for what we do now is we're going to try to find your y-intercept. So I'm going to be substituting 425 into the equation. So wherever I see x, I'm going to put 400. Wherever I see y, I'll put 25. Therefore, simplify this. So 0.025 multiplied by 400 gives you 10. To get rid of this 10 to solve for C, I'll subtract 10 by both sides, okay? And therefore, C is going to equal to 15. And we can tell over here that this does appear to look like it's going to equal to 15. Therefore, your final equation is this over here. This is the end of today's video. Hopefully that you guys got most of these answers correct. I'll see you guys again in the next video. Bye.